Okay, we're back. And in this part of the material that we're looking at, we're going to look at how to design an effective experiment. Okay, so we understand that there's this logical approach called the scientific method to solving any kind of a problem. Let me back up real quick and talk about what I meant by solving even a math problem. Okay, so when you're going to solve a math problem, your teacher gives you a math problem that they want you to find the answer to or find the solution for. So you look at the problem. That's the question. If you know how to do the problem, you may go ahead and try to solve it. But if you don't know how to do the problem and you're wondering like, okay, what did the teacher say about this type of problem? What was the example or the model that they gave? So you go back and you do the research. As you do the research, you find an example that allows you to solve the problem. Okay, so you think, okay, your hypothesis is, okay, so at that point you've done the research, you've come up with a question, you've done the research, your hypothesis is, if I do this, if I follow this example, then I'll find the solution to this problem. So you start working it out. That's the experiment. You start trying to answer that question. You get results, you get an answer. Okay, then you want to think about that answer. You don't want to just move on to the next math problem. You want to think about it. Sometimes in a math book, some of the answers are in the back. So you might go back to the back and you might check your answer to see if it's right. Or you might look at the answer and say, does this make sense? Can I plug this back into the math problem and solve it? Okay, does it solve it if I plug it back in? Once you've determined and analyzed your results, your answer, then you draw a conclusion. Okay, the math problem is solved. I'm ready to move on to the next math problem. So something as simple as a math problem still works through this logical approach. You don't just look at a math problem that you've never seen before and just start working it willy-nilly. Okay, you want to think through it. You want to come up with a logical approach to it. If you just do it willy-nilly, you may not ever come up with an answer. Okay, so that's the kind of thing that we're talking about with the scientific method. So in this part of the method, or this part of the material, we're going to actually look at some of the fine detail about the scientific method. And this is going to involve a lot of math jargon, okay, or science jargon. And you're going to have to pick up on that jargon because we will be using some of this throughout the semester. So as we talk about these and we define these, we want to make sure that you kind of incorporate that into your understanding. If you need to pause and go Google it to see if there's another way to explain it, then go for it. Okay, I'm not going to be insulted that you go out and you try to find another way to understand it. But you do need to get a feel for it. All right. So an experiment is the step-by-step plan you think through in order to test your hypothesis. So at this point, we already know what we want to test. This is how we set up an experiment. So if we want to test which plant will make or which soda will make a plant grow better, remember our little thought experiment from before, then we want to define the variables. Okay. The variables are the factors that could influence that test. And we've decided that Mountain Dew will make a plant grow taller. All right. So the independent variable is the first type of variable that we need to think through. And we've already kind of done that with our plant experiment. The independent variable, also known as the manipulated variable, I won't use that term for it though. I'll call it the independent variable. The independent variable is the one that is changed on purpose. Okay. You may have several levels of this, but you only want to change one type of thing. Okay, and what we're changing is what liquid we're using for our plant situation. Okay, so we're using Coke, if I remember these correctly, Sprite, and of course what we think is going to win, Mountain Dew. And water. We can't forget about the water because that comes in as an important factor later. So those are the things that we are controlling. We're controlling how much of each of these we're giving and which ones we're using. What we can't control is the height of the plants, right? That's going to be dependent upon what we feed it. How well the plants grow depends on lots of stuff, light, soil, water, how much water you give it. These are all water-based, okay? So that's a good thing about that. They're all getting some water, but they're also getting some extra stuff in these, okay? And we're trying to see if that helps or hurts, okay? Well, what depends upon these four liquids is the height of the plant, and that's called the dependent variable. The dependent variable is the one that responds to what we add to the plants, the variable that acts in response. Okay, in that case, it's going to be height. Now, there are other ways that you could probably measure how the growth, the best growth, but we're going to do that by height of plant. I've just decided that. And we're going to measure it in inches. Okay, that's a pretty standard measurement that you will have at home probably, either as a ruler or a yardstick or a tape measure. Okay, but something that has inches on it. Now, that's the only two things that we want to affect the plant growth: the water, the Coke, the Sprite, and the Mountain Dew. We don't want anything else to affect how high these plants grow. And we know that there are other factors that influence it, like light, for example. We don't want to put one of them in the dark because we want it to lose. We want to make sure that we keep some variables constant. And that's what they're called, constant variables. These are the variables that could also influence how high the plants grow, but we're preventing them from doing so. Okay, we're stopping it. It's all other factors in the experiment that are not allowed to change. And you're going to have to brainstorm for some of these, but there are tons. Okay, soil. What type of soil is in the pot? Size of the pot. Okay, we've already mentioned light. The amount of material, the liquids that we're using. We want that to be consistent. Lots of factors could influence this. So we just want to reason or brainstorm through to figure out how many different factors or what factors are going to influence this experiment and how high those plants grow. And we want to only anything that's not adding these 4 different liquids in a certain amount for each one and the height of the plant. Anything else, we want to figure out how to make it consistent. Okay, be constant. Now, the water, as I mentioned, the water is going to be an important factor here because that in some experiments, not every experiment will you need one of these, but in some experiments, you'll need a control group. Now, a control group is the part of the experiment that's just kind of treated normally. Okay, it gets normal treatment. Like normally, you give a plant water to help it grow, right? You water it, you give it enough light, and so on. Well, the control group for this, that's why we picked water. Otherwise, we wouldn't necessarily have picked water as one of our liquids. But we want to make sure that we pick water so that we have this control group, so that we can compare the growth to the normal. If we don't have that comparison, we won't know if it grew higher or slower or that killed it or what, all right? Compared to, so we have to have a control group. Everything else, the different types of soda, for example, are experimental group. Experimental group. All right, so water is our control group here for this particular experiment, this thought experiment. And our experimental group are the sodas, the pops. And there's 3 of those, remember, Coke, Sprite, and Mountain Dew. And we think Mountain Dew is going to win. So if you're going to set up your procedure, you need to think through these variables first. Because if we don't know what we're testing and we don't know how we're testing it, then we don't know what to write in the procedure. Because you're not always going to be given the procedure. Most chemistry labs, you'll be given a procedure because you don't know enough chemistry to come up with your own. So we'll give you a recipe to follow. But in this kind of situation, when we're trying to figure out what makes plants grow better, we don't have a recipe already pre set up for us. So we've got to set that up ourselves. And in order to write a good experiment, we've got to think through all these other things, all these other variables. Then we want to write an experiment with those variables in mind that will test our hypothesis. So we want to select only one thing to change. That's our independent variable. And in this case, that's our different types of liquids. Change a variable that will help test the hypothesis. The procedures must include a step-by-step list of actions of how that variable will be changed. Okay, we're selecting Coke, Sprite, and Mountain Dew from 2-liter bottles, basically with the same bottle date if we can. under the same, all refrigerated or not refrigerated, sitting out on the same kitchen counter for the same amount of time. All those kind of things we need to think through. All right, those could theoretically influence our answer here. All right, so we want to make sure we think through some of these issues, and I'm just brainstorming just now, coming up with some of those. So the procedure must be a step-by-step list of instructions, list of actions or instructions for how the variable will be changed. What are we doing? The procedure must include the type of data to be measured. Okay, so in this case, height in inches. Explain with a step-by-step list of actions or instructions how the change in the variable will be measured. So this is about the dependent variable. It must also explain how your constant variables will be held constant. Okay, so you need to, in your procedure, talk about the soil. Did you feed it with Miracle-Gro? Did you just use the soil that came from the store? But they were all bought at the same store at the same time. Okay, how much light you're giving it. If you put it on the kitchen counter, it's going to get light from a window, or you're going to put it out on the patio so it gets natural light. How are you going to set that up? Okay, how much of each liquid you're giving it. So you may want to do some research to figure out how much normally water you would give a plant every day, and then give that same amount to the other liquids. Okay, so there takes some thought and some processing going on here. You don't just throw some plants on the patio and start feeding it with this stuff and not think through how you're going to do that. All right, so you must show how the constant variables will be held constant. This is important, and it has to be in your procedure. Don't just assume that the other people that are reading your procedure know what you're doing. And it should indicate how many trials you're going to perform. Okay, so in the perfect world, you would have, if we're doing 4 different liquids, you might have 3 plants for each of the liquids. So you might have 12 different tomato plants. Okay, and you're trying to get an average of growth. You're not just assuming that one plant's going to do it. Okay, so with your 12 different plants, you would feed 3 of those water, 3 of those Coke in a consistent manner, 3 of those Mountain Dew, and 3 of those Sprite. And then once you get your data at the end, you would average the results to make sure and to see how each of those liquids affected the average tomato plant, not just the tomato plant that you tested. So you would want to do multiple trials. Okay, and this is an important step as well. So this procedure here is a list of instructions. It's a recipe of how you're going to do it. Now, good instructions don't leave any doubt as to how the test was made, or how the shelf was built, or how the brownies were made. Okay, they come with a list of instructions that is detailed enough that it can be repeatable, that anybody that picks up the recipe can follow through and get the same results. You don't want to pick up a recipe that wasn't written very well and try to decipher it to come up with a solution. Like if you hear it all the time about how poorly some instructions are to build in a shelf, something prefabricated. And then you're left with, like, IKEA's got a notorious reputation for its instructions of being extra complicated and hard to do. So you'll see that on like comedy shows, sitcoms all the time, about how somebody was trying to follow these instructions and ends up screwing up and the shelf falls over or something like that. All right. So you want to make sure that these instructions are just the information that you need, but all of the information that you need. Okay. So that's an experiment. You're going to be collecting data, and I've mentioned this a couple of times, talking about this as we collect the data. When we collect the data, you'll get 2 kinds of data, and these are the observations versus the measurements here. You'll have qualitative. I wanted to give you that vocabulary word. Qualitative data, which just has quality to it. This is comprised of a description of the results. It's a description. It's an observation. Okay, and then you have quantitative data. So when we're doing an experiment with these plants, we want to measure the height Okay, so these are measurements that we actually take. We want to measure the height of the plants, but we also want to pay attention to how green it is, how lush it is, how big the tomatoes are if they're already giving you tomatoes. Okay, so we want to give the observations as well, and we want to make note of those observations. We don't want to just do the data, because the observations help us to understand the data. All right, I need to redo that. Now, the results of the experiment, once you get these results, will be compiled into a data table. For easy interpretation. And not just for easy interpretation, but for somebody to come along that's going to reread your experiment. They don't need to read the whole procedure and figure out what your data is. What they want to do is they want to see, okay, this is the purpose. This is what we're trying to solve. They'll skip how you did it, and they'll skip down to the data, and they'll look at the data table, and then they'll look at the conclusion. Now, if they are intrigued by the conclusion, they may go back and figure out how you did it. All right. But the data table helps to organize stuff. It just gives you a way to organize it. Once you got the data, sometimes you can get a picture of the data by graphing it. Okay, and this just gives you a picture of the trend of the data, gives you a picture of what the data is doing. In the case of these plants, we might be able to just tell from the data table, okay, the average of this one did this, the average of Coke did this, the average of the Mountain Dew did this, and so on. Okay, but in some data, we want to get a picture of it, a graph, and we will deal with graphing during this year, interpreting graphs, and we'll learn how to make a good scientific graph as well. All right, so that's coming up as well. But right now, we're just focusing on an experiment. Okay, so let's look at this experiment right here and answer these questions real quick as an analysis of the experiment. So this is an experiment that somebody has already done, Mr. Krabs. He wants to make Bikini Bottoms a nicer place to live. He's created a nice sauce, a new sauce that he thinks will reduce the production of body gas associated with eating Krabby Patties from the Krusty Krab. He recruits 100 customers with a history of gas problems. He has 50 of them that he calls Group A eat Krabby Patties with the new stuff, and 50 that he calls Group B eating Krabby Patties with a sauce that looks like a new sauce but is really just a mixture of the mayonnaise and the food coloring. So it's the trick sauce. Both groups were told that they were getting the sauce that would reduce the gas problems. 2 hours after eating the Krabby Patties, 30 of the customers of the 50, 30 of them in Group A reported they were having fewer gas problems, and 8 in Group B, there were also 50 of them, also reported having fewer gas problems. Okay, so what we want to think through is we want to think through these different parts of the experiment itself and get that information from what we've read. Okay, so which people are in the control group? This is the ones that we treated normally, right? These are the ones that we didn't give new stuff to, okay, that we didn't test really. We just faked them out. We tricked them. All right, so in this case, that was the Group B, because they got the sauce that looks like new sauce but isn't. Okay, so that's Group B. So the independent variable then is not Group A. They're not the independent variable. They're the experimental group. It doesn't ask us that. It asks us what the independent variable is. And the independent, what they're testing is the two different kinds of sauces. Mr. Krabs is controlling that. All right, now how are they measuring that? Okay, how are they comparing Group A's results and Group B's results? And that's the dependent variable. What depends upon which sauce they get? What depends upon that is the amount of gas, right? Now they don't tell us how they're measuring that amount of gas, how many farts per hour or anything like that. What they're measuring, they don't really tell us how they're measuring it. They're just asking them if they feel better or not. So what should Mr. Krabs' conclusion be? Okay, what should he decide about his new fancy sauce? Well, we had 30 out of 50 do better, improve with the new sauce. Which, if you do that math real quick, we can get a percent for that, but it's going to be pretty high. That's 60% improved. And only 8 of group A or group B. This is group A. This is group B. 8 out of 50 improve with old sauce. And 8 out of 50 would be 16%. Okay, so you can see that more feel better with the new sauce than with the old sauce. So what should the conclusion be? It seemed to work. All right, so why do you think, though, that there were 8 that said they improved? Even though it was a trick sauce and it wasn't supposed to, why do you think 8 decided that it did, that it helped? Well, remember, he told all of them that they were getting the sauce that would reduce gas problems. Okay, so if somebody tells you, hey, I want to give you something that's going to make you feel better, sometimes, even if it's not really going to make you feel better, sometimes you feel better. Okay, and there's a term for that in the scientific community called the placebo effect. In any scientific experiment that involves medicine, okay, or a treatment of some kind, they will do a study in where that some of the patients receive the new treatment and some of the patients receive what's called a placebo. And it could be a sugar pill, or it could be something that looks like the other, but has none of the active ingredient in it. But nobody is told which group gets which or which person gets which. It's called a double-blind study. And nobody is told if they've got the good stuff or the bad stuff. Okay. So in this case, everybody was told that they got the good stuff, even though half of them got the bad stuff. And those that got the bad stuff, even though they got the bad stuff, at least thought, so it's mind over matter kind of thing, thought that they got the good stuff. So they felt better. That's the kind of thing that you want to think through. Now, you've got an experiment of your own to analyze after this. So if you need to go back and rewatch this or look at your notes or try to make sense of some of this stuff again, that's fine. But I do want you as a formative assessment, okay, something that you're going to get recorded to make sure that you're keeping up with us. Going to get recorded in Infinite Campus. I want to make sure that you've got a feel for how to set up one of these experiments, or at least analyze through an experiment. You want to set it up by answering the questions in the experiment section. And that will be, let's see, the quiz, no, experimental design practice. All right, so you want to take that little mini quiz. All right, thank you for paying attention, and please get in touch with me with any questions, okay?